this sort of scientific method. So there are 6 levels of thinking. There's a Bloom's taxonomy. This is like the most sort of sciencey I'm going to get with you all day, is talking to you about Bloom. It's the process to suggest that the process of thinking involves 6 different levels. And by age 3, children can use all 6, which means that year 0 to 3 is when they're really building the skills necessary to get there. All right, so what is that, Bloom, if you've never heard of Bloom's taxonomy? So the first is gathering knowledge, so that sort of foundation of acquiring the basic pieces of knowledge. The second is comprehension, confirming what they've already known or what they don't know. The third is starting for them to apply their knowledge. The fourth is analyzing. Fifth is synthesizing, putting that new knowledge together. And the sixth is when they evaluate. Just close your eyes for a second. I know this is dangerous to do at this point in the afternoon. And think about a young child approaching a table filled with water and cups and things that are floating, and how they approach that, and how they gather knowledge when they're there, how they are confirming the knowledge that they already have, or maybe they're discovering something new, how they're applying any new knowledge that they have gained as they are scooping and pouring and floating and sinking, how they're analyzing what they're learning, maybe how they're taking something that they've just learned and they're making a different choice with these familiar materials, acting upon it in a different way, and then how they evaluate what they've learned. And then open your eyes. And so think just that very simple setup of water and cups and scoops and funnels and something that sinks and something that floats really allows children to go through this entire process. So this kind of builds on each other, right? Like you have to have some basic knowledge before you can evaluate what you've learned. And sort of the sad thing is that most teachers tend to ask 90% of their questions in the knowledge realm. So we're sort of, testing what their knowledge base is, as opposed to helping them think differently, to apply that knowledge, to analyze it, to reevaluate it. So, one of the challenges, I think, for all of us is to think about, what do I need to do in my practice so that I stop spending so much time in that sort of base level of trying to figure out what kids know, and how can I move to helping them start to understand something more deeply or differently. All right, time check. Creative design. So creativity is often valued. Sometimes we think we don't have it. It can be very hard to define. And some people think creativity cannot be taught. That you either have it or you don't. So we're going to kind of think about that. So, I love this quote from Dorothy Parker, that creativity is a wild mind and a disciplined eye. So you have to have both in order to be creative. So really examining problems from alternative perspectives, stepping beyond what is possible, coming up with new solutions. So my example to this is always the thing that we all have with us today, our iPhones, right? You think about what the telephone looked like at its invention, and I can't tell you what year that was, because I lost that fact a long time ago, to what our phones look like now and what they do. We could have just stayed there, right? Like it's, like we could still be going to the wall and picking up the phone and having somebody at the other end of it physically connect the wires in order for us to talk to the people we want to talk to. But somewhere along the line, somebody said, there's got to be a better way, right? And they sort of, and the evolution got us to our cell phones, and there are lots of people right now who are saying, there's got to be a better way. I don't want to carry this thing around with me anymore. And then, what's it going to look like in 20 years? If I knew I'd peace out and go be a billionaire, but I don't. So that's an example of creative design. That anybody else have any other examples that pop to their mind right away?
Like the vacuum cleaner, and how how much that's changed from a vacuum where you put a bag in, and you have to empty, and there's a cord, a finite cord, to now you can take little vacuums that just accumulate in anywhere.
Starting from the typewriter, yep. Yep, Melanie?
Spreadsheets, like they had to write them on a board and recalculate stuff, and then, as you said, evolution happened and technology got better. We have it on like our Macs, and now we can type out spreadsheets, like the data changes as you put in new information, so now you don't have to do the work.
And if I would just learn Excel better, I could do that. Emily?
I wanted to give an example from my classroom of a kid, you know, we were sitting at the couch and there wasn't enough space for him. And he decided to go get a chair from the table and bring it over. And then he was sitting too. That was kind of creative.
Sure. Solving some problems. This quote says, "The creative adult is the child who survived." So science, art, and design are interrelated, and we think about science curriculum with kids. We should also be thinking about creative design. It's about building those problem solvers. Curriculum in all three areas really begins with a problem to solve. And when I first started thinking about science curriculum that way, it's totally changed the way that I approached science with kids. That it's not about you memorizing this specific fact or working your way through using this tool, but it's really about, well, what problem are we trying to solve together? Okay, so we're gonna do some creating now together, and here are the things that, I'll give you a little information here, and then I'm gonna set you up. So this is from the National Science Teachers Association position statement. That young children develop science and design skills by engaging in experiential learning. They engage in activities when an adult intentionally prepares the environment and allows children to fully engage with the materials. The activities allow children to question, to investigate, to make meaning, and to organize information by manipulating materials. So that's what I've done for you. I've created an environment for you. I've thoughtfully prepared some materials. And I'm going to invite you to think about a problem that you would like to solve, and then do some sort of physical representation of what your solution to that problem will look like. And right now some of you are like, let me get those materials, and some of the other of you are like, what is she talking about? So I will give you an example of this is what I would do. If someone said this to me, and I had the time that I've already had to think about it, I would say one of the things that I really wish would happen in my lifetime is that we would develop teleportation. I hate the amount of time it takes me to travel to get to anywhere, and I also know that like transporting people and materials from one place to the other is ruining our planet, right? So if I could solve that problem, again, peace out, see you guys later. But, so that would be the thing that I would really like to have happen. And so I would take some of these materials and try to develop some sort of representation of what that solution would look like. All right? So here's what you can do. You can work in your team, you can work with a buddy, you can work by yourself, you can work in a group of 5 or 6, I don't care, just work, that's all I care. And come up and grab some of these open-ended materials, and we're gonna do this for about 10 minutes, and then you're gonna come back and tell me what your problem was and the solution that you created.